Now we have our first question here on the board. We are asked to calculate the weight percent of sodium chloride in a solution. Now the solution contains 40.10 grams of sodium chloride. It contains 20.20 grams of methyl alcohol. Methyl alcohol is methanol. And then it contains 100.20 grams of water. Then the question proceeds, assuming that density of the solution is 1.10 grams per mole. What will be the molarity of methyl alcohol? We're given the molecular weights, alright, that's molar mass of sodium chloride, water, and methyl alcohol. We are to calculate the weight percent of sodium chloride, is that not so? And so we write weight percent, I'm going to abbreviate, alright? Weight percent of sodium chloride is equal to weight of sodium chloride is equal to weight of sodium chloride divided by weight of solution. Weight of solution. All we need to do is to add the weight of the component of the solution. Now if we are to do that, what would that give to us? That would be equal to, remember I need to multiply this by 100 to express it in percentage. And so we move on. Weight of sodium chloride as given from the question is what? That is 40.10. There is no need converting to kilogram here. Take notes. No need. It's the percentage you're trying to obtain, and you know that the weight of everything here is in gram. When you walk around, weight of numerator over weight of denominator, which is gram, they will cancel out. So you don't have any issues doing any conversion here. So we'll substitute 40.10, which is the weight of what? Sodium chloride, divided by weight of solution is the addition, the summation of the weight of the three components that make up this what? Solution. And what are the weights? 40.0, which is weight of sodium chloride, and then plus 20.20, which is weight of what? Weight of methyl alcohol, and then plus weight of water is 100.20. Multiply this by 100. All you need to do is to punch the calculator. I'm going to punch from here as well too. Alright, you can punch yours as well. So we have 40 as numerator divided by the denominator. We'll put everything in brackets, okay, so that the calculator will give us something correct. 40.1 plus 20.2 plus 100.2. Alright, take note, this 00 ending it is insignificant. So it's giving me 0.24922. Now that's 0.2492. Okay, let me pick 4 decimals, multiply by 100. If you multiply this by 100, you get 24.9%, which is approximately equal to 25%. So this is the weight of sodium chloride in this solution. We should take a break. When we come back, we'll solve the second part, that is the molarity of methyl alcohol. You're welcome from the short break. Now we want to determine the molarity of methyl alcohol. Of course, from the question we're given that density of the solution is 1.10 grams per mole. How do we go about this? You recall that molarity, when we're expressing terms used in getting composition of a solution, molarity of any particular component, which in this case, it is methyl alcohol, that is methanol, is equal to number of moles of that component, which is number of moles of methanol divided by volume of the solution. Do you recall this formula? Now we're going to multiply it by 1000. Is that okay? And having said that, how do we proceed with this? Number of moles of the methyl alcohol was not given to us in this problem. But you know that number of moles can be expressed as mass over molar mass. That is weight over molar mass of that component. So I'm going to write weight divided by molar mass, is that okay, of methyl alcohol, CH3OH, divided by volume of solution. How do I get volume of the solution? Because again, in the problem, we don't know the volume of the solution. What was given to us is the density of the solution. So at this point, you quickly need to recall the formula that density is equal to mass over what? Volume. Density is mass over volume. If this is true, then volume is the same as mass over density. Do you agree with me? So if you want to get the volume of the solution, it's going to be mass of the solution divided by density of the solution. So I'm going to write mass, or you can still use weight. Let's use W as we'll be using, divided by density of this solution. Is that okay? Then times 1000. All we need to do now is to substitute all of this. Weight of the methyl alcohol from the question is 20.20. Write it 20.2. Divide this by the molecular weight of methyl alcohol, which is 32. Everything all over weight of the solution. Weight of the solution is 40.10 plus 20.20 plus 100.20. That is the weight, because these three components makes up the word solution. If you add that up, you should get 160. Okay, let's add it up, please. Let's do that so that we wouldn't make a mistake there. 100.2, add it up to 20.2, add it up to 40.2. Okay, it's giving us 40.1 rather. 0.1 is giving us 160.5 divided by the density 1.1. Is that okay? And if you work out this, multiply by 1000 times 1000, you will see that the molarity will give us, okay, from here 4.33 moles per liter. So this is the molarity of methyl alcohol in this problem. We have this second question on the board. To determine the molality of a solution containing 86.53 grams of sodium carbonate, the molecular weight was given to us 105.99 per liter of solution. This per liter means 1 liter of the solution. Per means one quantity of that thing. Alright, in water at 20 degrees centigrade. So the solvent here is water. Density of the solution was given to us 1.0816 grams per ml at that temperature. Now, how do we solve this problem? You quickly need to recall your molality formula. You would recall that molality is number of moles of that solute divided by weight of solvent. Alright, then you multiply by what? 1000. And the question now is, how do we get the number of moles of the solute? Because it was not given to us from the question. What it gave to us is mass of the solute. The solute is sodium carbonate. So we are going to obtain the number of moles from the weight of that solute. Hence, the number of moles of the solute is going to be written as weight of solute divided by molecular weight of the solute. Is that okay? And then divide everything by weight of solvent. How do we also get it? Because from here, the weight of the solvent was not given to us. In fact, to get the weight of the solvent, the weight of water, all you need to know is that solution is equal to solute plus what? Solvent. So weight of solution will be equal to weight of solute plus weight of solvent. Which means if I want to get weight of solvent from there, it's going to be weight of solution minus weight of solute. I don't know if that makes sense, right? The weight of solvent will now be obtained from what? Weight of solution minus weight of solute. Alright? Good. You get your weight of solvent. The reason I had to go through that way is that I can easily get weight of solution from the density of the solution. Is that okay? Can get it. Then multiply this by 100. Now let us still work around this formula. It's going to be weight over molecular weight of the solute, then divided by, how do we get weight of solution? We know density of solution already. So we would use this formula that density is equal to weight over volume. So that weight is equal to density times what? Volume. So I will come over here in terms of weight of solution. It's going to be density of the solution times volume of the solution, which of course is liter. 1 liter, you convert it to mil. 1 liter is 1000 mil. Is that okay? So this is of solution. We're going to subtract weight of solute from it, which we know from the question, weight of solute. So we can now use this formula to get our result. Let's substitute. Weight of the solute is 86.53, and then divided by molecular weight is 105.99. Everything all over density of solution is 1.0816 times volume is 1000. Remember, you multiply this by 1000. Okay, so subtract weight of the solute from it, and the weight of the solute is still 86.53. Multiply everything by 1000. Now, if you work out the numerator and work out the denominator, what are we going to get? If you work it out, these two numerators, okay, they divide, and then this times 1000 minus 86.53. Divide this numerator by what you have in the denominator. You're going to get 0.8204. Alright. This term here represents what? Number of moles per weight. That is moles per grams. Is that okay? And this is the molality of our solution in this problem.